Hi, I'm Sharmishta Chatterjee. I'm a product engineer in the spatial analyst team in Esri Redlands. Today, I'm going to show you environmental annotation of multidimensional ocean data across space and time. Environmental annotation is understanding and modeling the distribution of animals by linking each observation with its associated environmental variables. Inexpensive tracking technologies and the adoption of machine learning have resulted in a dramatic increase in the availability of temporal and spatial resolution of animal location data in various formats. Now, bringing this data together can be difficult. So, in this presentation, we will explore how to assign, visualize, and summarize environmental attributes like sea surface temperature and chlorophyll at animal locations or within home ranges using recently enhanced tools in ArcGIS Pro. We know that the North Atlantic right whales have been listed as endangered since 1970, with only about 400 of them left currently. So I'm going to use this data from the Ocean Biodiversity Information System for this study. Now, before we begin to annotate this observation, let's take a quick look at the temporal distribution of this data using the data clock. From the data clock, I can quickly see that I have data from 2008 to 2017. From the dark blue wedges, I can see that my data is mostly between May and September. If I select my wages, I can see the distribution of the whales spatially on the map. Now that we have a better understanding of when and where these whales are located, let's get started with the annotation. Let's start with the simplest case of annotating a series of points using environmental data from a single raster. I'll use the whale observation and a long-term average of sea surface temperature data from ArcGIS Living Atlas. This will require reading the data, doing a temporal aggregation, and finally doing the environmental annotation. In the Make Multidimension Raster Layer tool, I'm reading the daily sea surface temperature as a multidimensional image service from Living Atlas. This tool can also read other data formats like NetCDF, HDF, GRIB, and CRF. Next, I'm going to use the Aggregate Multidimension Raster tool to aggregate the daily data to create the long-term average of sea surface temperature. Finally, I'm going to use the Extract Multi-Values to Point data to extract the temperature at each observation. In this case, I'm using the bilinear interpolation. This adds the temperature to the point in a new column. Now this data is ready for additional modeling. As you can see, we can annotate large collection of observations fairly quickly by extracting the values of an underlying raster at the exact location where the observation was made. However, for highly mobile animals such as whales, the mean sea surface temperature at the exact location might not always be a good representative of its environmental conditions. In addition to that, there can be imprecise human observations or GPS positional inaccuracies. To account for that, we have enhanced the sample geoprocessing tool to aggregate the cell values of a buffer area around an observation before sampling the raster. Now, buffering based on a fixed value is useful if you know the typical movement pattern for an animal or a particular type of positional inaccuracy of the GPS points. Buffering based on a field is useful if observations have different movement patterns or different levels of locational uncertainty. In this case, I'm using a buffer of a fixed value. From the table output, you can see the sea surface temperature for each observations from the buffer are annotated and reported in a new table. Now we know how to work with spatial uncertainty by using a buffer distance around the location. However, that may not always be sufficient. For example, if I have a historical data. In this case, say if a whale was observed in August of 2015, I may want to know the sea surface temperature at that location in August of 2015. The temporal capabilities of the sample tool are quite powerful, and you can specify a particular time slice or automatically summarize a range of data around when the well was observed. For example, you could summarize sea surface temperature 3 days before the well was observed, 3 days after the well was observed, or a span of time when the observation was made. This temporal sampling approaches allows us to begin to explore how animals might respond to environmental conditions. We can account for spatial uncertainty and the time by combining these two features. In the new table output, you can see observations only from August of 2015 are annotated, considering the spatial buffer, and you can see the exact dates when these well observations were made. Now that we have annotated the sea surface temperature data to the points, let's look at another example of how we can annotate distribution of chlorophyll in the calving and feeding areas of these whales. I've downloaded the calving and feeding areas from NOAA and the chlorophyll A data from the Living Atlas. I have then aggregated the chlorophyll A data to a mean monthly data for the last 20 years. Let's take a quick look at the distribution of chlorophyll A in these two areas. To do that, I'll use a temporal profile. These are my calving areas. I'll select a different color for my feeding areas. Let's increase the symbols a little bit so that we can visualize it better. And let's do the binning in a yearly manner so that we can understand the pattern better. Now, from the points that I have selected to create the charts, the calving area has more chlorophyll content than the feeding area. Let's take a deeper look at it by calculating the summary statistics. To calculate the summary statistics at these areas, I'll use the zonal statistics as table tool processed as multidimensional. From the zonal statistics as table output, I can see the summary statistics for each month of each year for the feeding and the calving areas. This morning, we have visualized how to do temporal annotation by using data clock and the temporal profile, how to assign environmental variables using the extract multivalues to point and the sample tool, and have summarized environmental variables using the zonal statistics as table tool. All our environmental annotation was done across time. However, the good news is that you can use the exact same tools to annotate your presence data across any other dimensions like depth or altitude. We hope that these new tools and capabilities will help you in your workflow. Thank you.